So what I'm going to do in this video is show you how to construct a model of the fluorite structure. So fluorite is calcium fluoride, so you're going to have calcium ions and fluoride ions. Coordination number is 8 to 4, so we're going to use a combination of 8-prong atom centers and 4-prong atom centers. Calcium is going to be silver, that's the 8-prong centers, and the fluoride is going to be purple, that's the 4-prong centers. So this structure is based on a face-centered cube. So we're going to start this with basically one face of our face-centered cube and then build it out, right? So we're going to have our 4 vertex atoms in this face, and we're going to have one atom in the center of this face. Alright, so we're going to begin by adding the fluoride ions. Now, if we continue to think two-dimensionally for just a minute, and we divide this up into 4 smaller cubes, alright, then the centers of each one of those will be a tetrahedral whole. And when we build it out in 3 dimensions, there's going to be 8 of those total, 4 and 4. So we're going to bridge each of these, start by bridging each of these vertex atoms to that center face atom. Alright, so we're going to add 4 of these. There's going to be one here, and one there, and third one here, alright, and a 4th one there. So here we have a start of our structure. We have this kind of spidery looking structure. Okay, so obviously a cube is going to have 6 faces. A face-centered cube, each face of the cube is going to have an atom in the center, right? So we've got the bottom face, and this atom is in the center of that bottom face. We're also going to have a left face, a right face, a front face, and a back face. We're going to have an atom in each, a calcium, or calcium ion specifically in each one of those faces. So we'll add this here. So that's going to be the center of our right face. And we'll add this here. Okay, that's going to be the center of our back face. We'll add another here. And that's going to be the center of our left face. And we'll add a 4th one here, and that's going to be, alright, that's going to be the center of our front face. So this is what we have so far. And notice we've started to create these diamond-shaped faces, and we also have the beginning of what looks like is going to be kind of a cage structure. Now ultimately, we now have 5 of our 6 faces: the bottom, the left, the right, the front, and the back. And there's going to have to be one on top here to make the 6th one, but we're not quite there yet. We've got to add 4 more fluorides. So we're going to go here to here, like this, okay, like that. We'll go, that will be the first, that will be the second, the third, okay, and then the 4th, okay. Now this is what we've got, okay. We're almost done, so now we can add our 6th face atom. Okay, and so now we definitely do have almost kind of a cage structure here constructed from these diamond-shaped faces. Now we're not quite done yet. There's 4 more atoms that we need to add, coming off there and there and there and there. Alright, and that completes the construction of this unit cell for fluorite. So basically we can turn this, all the sides look the same, so we can turn it this way, you can't tell the difference. We can turn it this way, you can't tell the difference. We can turn it the other way, you can't tell the difference. Okay, all the sides look the same, this is a cube. Now, what is this sort of, like I said, almost cage-looking structure here? If you remember, I said fluorite is based on the filling of tetrahedral holes. So the octahedral holes are not occupied. And that's basically what this is. This hole in the middle is basically an octahedral hole. Remember that it takes 6 atoms to define an octahedron, and that's what we have here. How many atoms are defining this center? It would be this one, this one, this one, this one, this one, and this one. Each of those is a face atom, right? This is our top face atom, that's our bottom face atom, that's our right face atom right here, our left face atom, our front face atom, our back face atom. So it's the 6 face atoms of the cube that are defining that hole in the middle, and that's a vacant octahedral hole, which is not filled in the fluorite structure. If you wanted to, you could keep building, you could come out, we could build this on, we could build out another unit cell to the left or to the front, but that's pretty much the fluorite structure.